Hello, we are team number 7. I'm Achyut Rajla and I'm going to demonstrate the work we completed so far. And here are my teammates, Rajiv, Shivani, Prasuna, Nikita and Varshik. They're on call and I'm going to demonstrate the working software. So this is a script I came up with to control the movement of the rover. And you can open Gazebo with the model in it using command one, which I already did. And here I'm going to insert a boundary for this environment to ensure the rover doesn't go out of the testing ground and cause unexpected results. Okay, so passing to it initiates movement in rover, and then we can set the velocity and the speed of the rover. Say I give 4. Now it increases the speed of the rover and exit out of it. I give command 3. So it starts going back, and then I can give command the set speed to 5 equals faster. Then I exit out of this. I give command 4 to stop the rover and 5 to make it move in circles clockwise, and then 6 for counterclockwise, and 7 to exit. Coming to individual contributions, I'm Achit. So I've been working on the entire development is in Ubuntu. I got an overview of ROS architecture and the flow of data in ROS network. I was able to run turtle simulation and spawn multiple turtle sims into existing network using RQT. Then learn to construct the gazebo environment. And eventually, I was able to build a boundary you can see in the virtual map, and then I was able to spawn the rover into the gazebo world and came up with a Python script that takes input from user from CLI and pass it to the rover in gazebo to engage movement. Then learn to add custom meshes to the test rover and define physics to it. Varshik. After resolving issues with the initial setup, he then implemented the logic to check the current state of the rover and only then take inputs from that controls the speed of the rover. This ensures that the movements are under control. Nikita. Nikita completed installations and the environment setup. Initially, she faced issues with RVs and gazebo installation. She also researched on PubSub architecture and was able to do turtle simulations. Then she came up with few test cases that helped us to thoroughly test the script before we merged our code together. Then Rajiv faced issues with installation initially while working on VirtualBox. Later, dual put his PC and installed ROS2. Faced issues with installation packages, which he eventually resolved and was able to do turtle simulations. And moved on to working with this task, which is working on sensor data. He tried to get the result back, but faced some errors in the code, so he's currently debugging the code. Shivani. VM was not working for Shivani, so she booted the PC to Linux. Also was able to run TurtleSim. She was working on a task of user story 19 for processing data from sensors while trying to save an enclosed map for the rover environment. She faced issues in Gazebo package integration with SLAM library. Prasuna. Initially, she faced issues with VirtualBox installation on M1 chip Mac. She shifted to Windows and finished setting up her environment. Then Prasanna researched on ROS and tested TurtleSim. Also, she researched on PubSub architecture and configured the rover according to GoPygo core. Then I'll quickly show you Taiga word. This is a word on chat. It looks like this. And this is story number 27. And these are the tasks. Adding rover to the movement is assigned for me. Established control for the movement is Varshik. Testing for movement in all directions is Nikita. Correct. This is story number 19. Task number 21 is assigned to Shivani. Task number 20 is for Rajiv, and task number 22 is for Prasuna. Everyone in the team could set up the environment after overcoming various blockers and installed all the necessary packages for ROS2, RVs, and Gazebo. We successfully ran a simulation of TurtleSim. We were also able to build a rover that is similar to GoPygo code to test our simulations. We could attain control over the rover's movement and also its speed. All these tasks were associated with user story number 27. We ran into some critical issues while working with user story number 19. The requirement for user story number 19 was difficult to implement. It took us longer than expected to go all the tasks, and we only realized it after sprint 1 started, and couldn't further modify the sprint and remained with tasks that were difficult to implement in the time frame. We therefore came up with more reasonable user stories for following sprint. But on the brighter side, at the end of the sprint, we could complete 4 story points out of 6. That's around 67%, closing one user story. And we now have a better understanding of the user expectations for the next sprint, so we did achieve decent value for the product for this deliverable. Thank you.